In this problem, we're taking a look at a company's business model, or at least some smaller part of it. And this is a company that does technical support for TI-89s, and they hire some employees and they make some revenue based on the number of calls that they get and how many of the calls are from registered users and how many are from general users. So the first thing we want to do is to write the company's monthly revenue as a function of the number of calls it takes. Okay, well, we don't necessarily know how many calls it takes, but we'll go ahead and mimic a couple of them to see kind of how this would work. So let's just say that we have calls, and then we have, let's see, the number of registered calls that they get, and then the number of general. And then we'll create one more column to build the revenue generated from that. So this is monthly number of calls. Let's just suppose they have a really weak month and they only get 100 calls. Well, we're saying that half of those tend to be 99-cent calls. So those are the registered users. So they will earn 99 cents 50 times, which 50 times 99 will be 49.5. So they will earn $49.50 from the registered users, and the other 50 will be general non-registered members, and those will pay $3.99 for the call. So 50 times $3.99, they will earn about $199.50 from them for that month. So their total revenue will be the sum of this plus this, which will give us $249. So this will be $249 earned from here, and here gives us this. Okay, what about 1,000 calls? Well, if it's 1,000 calls, then half of them are going to be 99-cent calls again. So 500 would be 99-cent calls, and that amounts to $495. And 500 of them would be $3.99 calls, so that would basically be $1,995 for a total of $495 plus $1,995, $2,490. I should have known that. Just be an extra zero. Okay, well, what's the pattern here? Well, the only variable is calls. So we'll go ahead and call that, let's just say little c. So we'll call that little c. Well, what if you made c calls? Well, if you made C call, if you got C calls that month, then half of those, so C over 2, would be at the 99-cent rate. So if it was 100, it'd be 50. If it were 1,000, it'd be 500. And then C over 2 calls would be bringing in $3.99. Well, the total here would be C over 2 times 99. Plus C over 2 times $3.99. So this would be my total revenue for that month. So if I let capital R be revenue, then I have, well, let's see, 99 divided by 2. So I'm going to simplify this a little bit. So 99 divided by 2, 1/2 of that would be 0.495. So 0.495 C. Because keep in mind it would be 0.99 C over 2, so I'm just getting rid of the 2, plus 3.99 divided by 2C, which would be 1.995 C. And now because these are like terms, I can combine them. So I'm going to add 0.495 to that, and that gives me 2.49 C. So on average, really, I'm going to earn $2.49 per call. Only 99 cents in one place, but $3.99 in the other. So in fact, the average between these two is $2.49. Okay, so there's my revenue function. So the table hopefully helped simplify that a little bit. In part B, we want to write an equation for the company's monthly cost as a function of the number of calls it takes. Okay, well, what kind of costs do they have? Well, they have employee costs because they've got to pay them. They have employee costs. They also have this overhead which we'll call it overhead, and that's just the $2,000. So every month they're going to be responsible for $2,000 in overhead. We'll calculate the employee costs in a second. And then also, in this case, we're told that the cost associated with each call is negligible since employees are paid to talk with customers. Okay, so there's actually no materials that go along with this. So regardless of how many calls they take, $2,000 will be the overhead. And they have 15 employees. They're paid $12.20 per hour each, and they work for 8 hours per day, 22 days each month. Okay, so that means that they'll earn $12.20 for 8 hours for 22 days in that month, because I want to figure out what are their costs on their monthly costs. But now this is only what one employee will require in terms of payments. So we need to multiply this by 15 because we have 15 total employees that need to be paid this amount. So $12.20 times 8 hours times 22 days. So they'll earn $2,147.20 each. By 15, that means their total outflow is going to be $32,208. So $32,208. And so the total cost, again, doesn't really matter how many calls you make. It's going to be $32,208 plus the $2,000, and that's going to be $34,208. Now, how do we write that as a function of calls? Since if we put a calls column over here, regardless of how many there would be, this would always be the cost. So our total cost, I'll draw a big capital C, is going to just constantly be $34,208. So if we wanted to incorporate the little c in there, like, okay, well, what about the number of calls you make? We could say $34,208 right off the bat, plus 0 for every call we make. Now, you don't need to show that because it's just 0, but now we can incorporate as a function of the number of calls made. Okay, so now we want to find the company's profit as a function of the number of calls it takes. Now, we recall that profit, capital P, is the revenue, what you bring in, minus what you ship out in terms of money. And now our revenue is given by 249C minus our cost, which is $34,208. And we've got our price, our profit function. So obviously, if you don't make any calls, you're going to be out a lot of money. So you have to pay a lot of employees, and you're also going to have to pay your fixed overhead. But as you make more calls, this term will become more positive. Subtracting away this big number will become less and less impactful once we reach a certain limit of calls. In Part D, we want to write an equation for the company's average monthly profit as a function of the number of calls it takes. Okay, so for Part D, well, depending on what the profit is, an average is going to be based on the average per call. So first we need to come up with calls, then the profit from the calls, and then the average profit. So let's just give a couple examples. 100 calls. If I make 100 calls, my profit will be 249 times 100 minus 34,208, which equals, that's 249 minus 34,208, which is negative 33,959. So big, major losses in profit here, not enough calls, and so my average profit will be, per call will be negative 33,959 total, divided by the number of calls I made, which will be negative $339.59 per call. Wow, so huge losses there. Every call cost me a lot of money, but hopefully as more calls are made, this will turn out to be better. So let's just say, pick a really big number, we'll pick 10,000. So if 10,000 calls were made in that month, we have 249 times 10,000 minus 34,208, which will give me 1, 2, 3, 4. This will be, well, let's just do it in the calculator. 249 times 10,000 minus 34,208, which is still a big loss, a loss of negative 9308, or excuse me, a profit of negative 9308, or a loss of $9,308. So if I divide that out by the total number of calls I make, the average loss per call is now only 1, 2, 3, 4, moved over 4 decimal places, is now only about 93 cents per call. So a lot less, but still really a bad thing. This company is not making any money. It's not able to meet its costs. So hopefully, at the very least, we'd expect the profit to be 0, so that the revenue earned takes care of at least the costs that are associated with running this business. Okay, well, suppose you make, so here's calls, profit, and here's average profit. Suppose you make C calls. Well, if you make C calls, then you make 249 times C minus 34,208 in profit. Well, now it looks like we're taking the profit and dividing it by the cost, so that's going to be 249C minus 34,208 divided by the number of calls I make, and there it is. Average profit is 249C minus 34,208 divided by the number of calls. Now, because I need to operate on this, I'm going to simplify it a bit. I'm going to separate this fraction into 2 terms, 249C over C minus 34,208 over C, and I can cancel out C's here, leaving me with 249 minus 34,208. And because I'm going to need to take a derivative of this in the next part, I'm going to move the C to the top, keeping in mind this is a first power here. So I'll move it to the top, make it a negative power, and there it is. There's my average profit function. Now in the next part, we're asked to find the instantaneous rate of change in average monthly profit when 5,000 calls are taken. So now we want to find AP prime. Well, AP prime, the constant's going to go away. I'm going to bring down the -1, multiply it by the -34,208, so now I'm using the power rule, and I'm going to subtract 1 in the exponent, giving me a derivative function of positive 34,208 c to the -2 power. So this is going to give me the change in average profit. And what are the units for this? Well, profit is in dollars. Average profit is in dollars per call. That's my change in output. My input is the number of calls. So as I make more calls, my dollars per call is going to change. And now I'm going to find AP prime of 5,000, which is going to be 34,208 times 5,000 to the -2nd. So 34,208 times 5,000 to the -2nd, and that gives me 0.0014, and this is what's happening to my dollars per call So what does this say? Well, if I'm making 5,000 if I'm receiving 5,000 calls, then my average profit, my dollars per call, is actually increasing by $0.0014 for every additional call I make. So it's kind of a strange thing. In other words, to think about it, is my average profit is increasing by 0.0014 per call. So this is average profit. For each additional call, this is what happens to my average profit. It increases by that much. That's not my overall profit, that's my average profit. Okay, Now, why is this actually increasing? Because what we're actually noticing is if you were to graph our average profit function, it looks like this. Our average profit is actually, excuse me, not like this. If you were to graph our average profit function, it would actually look like this. Starts off very negative at first, but works its way slowly to become more and more positive. Well, even though a profit's negative, we notice that going from 100 to 10,000 calls made our profit not, well, it's still negative, but it's a greater profit, right? Because this is less of a negative number, meaning it's moving more towards positive numbers. So even though we have a loss, our loss is getting smaller and smaller, which means our profit is actually growing. Strange thing, huh? Now, AP prime of 10,000 is going to be the same thing except evaluated at 10,000, so I will go ahead and hit second enter and just change my 5,000 to a 10,000. And I get something very, 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 very small, 0.0003 dollars per call per call. Wow, okay, so as I begin to make more calls, each additional call doesn't affect my average profit very much, which should make sense. If you think about it, if you have 10,000 numbers and you take their average and you add one more number, how drastically can that one extra number possibly affect your average? And the answer is obviously a lot less than if you go from 5,000 to 5,001. And that's kind of our real world implications here, that each additional call doesn't make that much of a difference anymore. But obviously we want to make tons of calls. This business, having only 15 employees and requiring well above 10,000 calls in order to make a positive profit, is probably a little bit of a risky situation.